A system of linear equations. It is a linear system. It's a system of equations in which all of the equations are linear. Basically, anytime you have more than one line, you have a system of linear equations. So the solution of a system of linear equations is any ordered pair that satisfies all the equations in a linear system. An ordered pair, if you recall, is coordinate points, x, y. An example, the point 1, 2. If that's a solution of the linear system of linear equations, it's the point 1, 2. So a consistent system is a system of linear equations with at least one solution. An independent system has exactly one solution. A dependent system has infinitely many solutions, otherwise known as this symbol. That's the infinity symbol right there. And an inconsistent system has no solutions. So, and let's take a look at an example. So if you recall, if you're looking for stuff in y is equal to mx plus b format, m, of course, is your slope, and b is the y-intercept. So let's find the y-intercept of 2. It's right there. And this goes downhill, down 1 over 3, or down 2 over 6. So let's see, 2, 6, 2, 6. So that's this line right here. And let's see, this one we're going to have to do some math. We're just going to have to subtract 4 from both sides. You get y is equal to negative 4/3 x minus 4. And now let's plot that line. Y-intercept of negative 4. Pick a different color. Going down 4/3. 1, 2, 3, 4 over 3, or up 8 over 6. So that's going to be right there. So now we've plotted both of these lines, the point at which they intersect. Where they intersect, it's right there. And that is the point negative 6, 4, and that's a solution for this system of linear equations. And what's it mean to be a solution of a system of linear equations? Well, you can find out right here. If I plug in basically the point negative 6 and 4, so now let's plug in our point negative 6, 4 into each equation, and recall that these are x points. Negative 6 is the x value, 4 is the y value. So what happens when you take a negative 1/3, multiply it by a negative 6, and then add 2 to it? Negative 6 divided by a negative 3, right? This becomes positive 2. If you were to multiply these together, you get 2 plus 2. And 2 plus 2 equals 4. So when x is negative 6, y is 4, at least for this equation here. And what about this one? Let's show its slope-intercept form. Now let's plug in, again, a negative 6. Negative 4/3 times the negative 6 minus 4. 6 divided by 3 is negative 2. Negative 2 times negative 4, positive 8. 8 minus 4 is equal to 4. So you can see that this point, negative 6, 4, is true for both equations, or for both lines, if you will. So if I'm looking at this next example, I know where the arrow is, that negative 4 is a y-intercept, right? Because anything in slope-intercept form, that's the y-intercept, that's the slope. The slope is a positive 4/3, so I'm going up 4 over 3, and then up another 4 over 3. Down 4 over 3, and so here you get the idea. Here is this line. Right here, right here, right here. This other line, y equals 4, simply that line right there. So these two intersect at the point 6, 4 is where they intersect. And this point 6, 4 should be true for both equations. If I take 4/3, multiply it by 6, and subtract 4 from it, you're going to get basically 2 times 4. So this is 8 minus 4. Is that equal to 4? Yes, it is. And for the second part, y equals 4. There's no x to plug in. If you can imagine, this is like 0x plus 0x. So if I did 0 times 6 plus 4, what does that equal to? It's equal to 4. So this is also true. That's basically what the intersection of two lines is. It's the point at which both lines, the point makes both line equations correct or true. So here's one more example. We know the y-intercept here is positive 5. It's going up 1 over 2. 1 over 2. 1 over 2, so on. Get a line, something like that. And then this, we're going to have to do a little bit of subtraction. I don't like that one. Let's actually subtract the 2/3 x. So here we've got a y-intercept of negative 2. It's going down 2 over 3. So down 2 over 3, up 2 over 3, up 2 over 3. So they're going to meet right there. Down 2 over 3. That's going to be this line right here. And they wind up intersecting at the point negative 6, 2. Right? Remember, these are x, y coordinates. And then we can find out, does negative 6, 2, is that true for both equations? Let's find out. 1/2 times the negative 6 plus 5. This winds up being negative 3. Is negative 3 plus 5, 2? It sure is. And let's check this one out. Let's use the slope-intercept form. It's negative 2/3 times the negative 6 minus 2 equal to 2. Well, this becomes Negative 2 times negative 2, which is 4. So this is essentially 4 minus 2. And that is in fact 2.